This is Algebra 2, Unit 10, Lesson 6 on simplifying rational expressions. Now, if we have a rational expression and we want to simplify it to its lowest terms, that is basically we're reducing a fraction. Remember, a fraction is a fraction is a fraction. It doesn't matter if it has numbers in it or if it has algebraic symbols in it. The process is still the same. So, let's take a look at reducing or simplifying rational expressions. Let's start with an actual numerical fraction, 18 over 12. All right, now if we reduce this, 18 over 12, what we're actually looking for is a GCF of both of those terms. If I look at a GCF of both of those terms, what goes into both of those terms? What's the biggest value? Well, it'd be 6. We can rewrite 18 as 6 times 3, and we can rewrite 12 as 6 times 2. Now, if I split this up into separate products, this is 6 over 6 times 3 over 2. Well, 6 over 6 just equals 1, times 3 over 2 is equal to 3 over 2. So when you are taking out a GCF, basically that's what you're doing. You are factoring out the GCF and then canceling it out to equal 1. Now, the same thing is true for an algebraic fraction. Now, when you have an algebraic fraction, you want to factor each numerator and denominator first before you try to reduce. So let's take a look. X squared minus 9. Well, that factors as difference of squares, x plus 3, x minus 3. And in the denominator, we have 2 times x plus 6. Well, that factors by GCF, 2 times x plus 3. Okay, now, what is being multiplied in both the numerator and the denominator? Well, it would be the x plus 3, this right here. Okay? Because we could rewrite this as x plus 3 over x plus 3 times x minus 3 over 2. So this will cancel this, leaving a 1. So your answer is just going to be 1 times x minus 3 over 2, which is just x minus 3 over 2. And that's fine. So when you see the same binomial in both the numerator and denominator of a rational expression, it will cancel out to be 1. And that's what we're looking for. So just to reiterate, every time we simplify a fraction, we are essentially finding all common factors of the numerator and denominator and dividing them out. All right, so in order to do this process, you must factor the numerator and denominator, and only common factors cancel each other. This is true whether it's got a binomial, or polynomial expression. So it has to be factored first and only cancel if it's exactly the same. All right, now monomials are really easy because all you have to do is simplify the numbers and then simplify the variables and deal with the exponents. So technically, this is what this is. This is 3 over 6, x to the 5th over x to the 8th, x to the 8th. And then y to the 6th over y to the 3rd. 3 over 6 is 1 over 2. X to the 5th over x to the 8th. If we simplify the same base when you're dividing, you subtract them. And to keep the exponents positive, we want it to be where it's larger. So it's larger at the bottom. So this is going to be 1 over x to the 3rd. Technically, it's x to the negative 3rd, but it can be written as 1 over x to the 3rd. But save yourself a step. And then y to the 6th divided by y to the 3rd is just going to be y to the 3rd. And then over 1, multiply the numerators is y to the 3rd. Multiply the denominators is 2x to the 3rd. So in our brain, this is actually what we're doing. With monomials, you probably should be able to do this in your head. All right, so if I take 20x to the 10th, y to the 8th over 4x squared. All right, 20 divided by 4 is 5. Technically 5 over 1, so that will go on the top. X to the 10th divided by x squared is x to the 8th. Bigger in the numerator, so it goes in the numerator. And then y to the 8th goes up here. Technically, there's a 1 in the denominator, so your answer is 5x to the 8th, y to the 8th. Okay, let's see if we can do this one. 7x cubed y over 21x to the 5th, y to the 8th. There's my fraction bar. 7 over 21. Well, 7 over 21 reduces to be 1/3. So the 1 would go on the top, 3 would go on the bottom. X to the 3rd divided by x to the 5th is x to the negative 2 technically, so where it's positive would be on the bottom. So this is going to be x squared on the bottom. Subtract the exponents and it's bigger on the bottom. And then y over y to the 8th, it's bigger on the bottom. So remember, this is really y to the 1st, so it's going to be y to the 7th in the denominator. This is Algebra 1 stuff. This is what we should remember from back then. But be very careful, watch your exponents when you're doing this. So let's see if we can work this one out. Which of the following is equivalent to 10 over 15, x to the 6 over x squared, y cubed over y to the 6th? Okay, well 10 over 15 reduces both by 5, so that's going to be 2 over 3. The x's, subtract the x's because you're dividing, and put it where it's bigger. It's bigger in the top. 6 minus 2 is 4, so it's going to be x to the 4th. All right, then y to the 3rd divided by y to the 6th. It is larger in the denominator, so it's actually going to be y to the 3rd. So it's 2x to the 4th over 3y to the 3rd. And that is number 3. All right, now monomials are pretty easy because everything is right there. When you're doing rational expressions that are more complex, it's a little trickier because you always have to factor first. Always factor first, then identify the common factors that can be eliminated. So basically, factor, 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 cancel, 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 cancel. That's what you do when you see these. So, x squared plus 5x minus 14 over x squared minus 4. Before I do anything, I'm going to factor the numerator, I'm going to factor the denominator. So I'll factor the numerator, double bubbles, x times x. The factors of negative 14 that add up to 5 would be 7 and 2, so it would be positive 7 and negative 2. All right, and then x squared minus 4 is a difference of squares. That factors as x plus 2, x minus 2. All right, is anything in the numerator and denominator identical? Yes, the x minus 2's are identical. They factor out to be 1 technically, so they cancel each other out. So what's left? X plus 7 over x plus 2. And that is simplified. All right, let's try another one. 4x squared minus 1 over 10x minus 5. Factor, 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 factor. Okay, now 4x squared minus 1 is also a difference of squares, two terms, both perfect squares. This is going to be 2x and 2x plus and minus 1. Okay, now the denominator, 10x minus 5, will factor by GCF. Factor out of 5 and divide this, it comes out to be 2x minus 1. Make sure that you have to be able to remultiply this, so make sure the 1 is there. Okay, now, is there anything identical in both the numerator and denominator? Yes, it is. 2x minus 1, 2x minus 1. So what's left? 2x plus 1 in the numerator and 5 in the denominator. Okay, so factor, 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 cancel, 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 cancel. All right, 3x squared plus 14x plus 8 over x squared minus 16. 3x squared plus 14x plus 8 will double bubble. Let's watch your signs, your numbers. It's going to be 3x and x this time. Plus and plus. The factors of 8, one of them multiplied by 3, that'll give you 14. So for 8, we've got 1 and 8, and we've got 4 and 2. Which one would we want to multiply by 3? Well, probably the 4, because 8 would be too big, and the 3 would be too small. So the 4 would have to go here, and the 2 have to go here. That gives me 12, and 2 gives me 14, so that works. And then x squared minus 16 is another difference of squares. That's x plus 4, x minus 4. Okay, what factors are identical? Well, it would be x plus 4 and x plus 4. So what's left is 3x plus 2 over x minus 4. Okay. Now, a special type of simplifying occurs when the expressions of the form x minus y and y minus x are involved. Basically, if you have the same numbers but in a different order and you're subtracting, what happens with the factoring? Well, let's simplify each of these fractions. 9 minus 6 is 3. 6 minus 9 is negative 3. What does that reduce to? It equals negative 1. 15 minus 3 is 12. 3 minus 15 is negative 12. 12 divided by negative 12 is negative 1. Okay, so what happens when you have a minus b and b minus a? Well, aren't they the same thing switched around? Technically, if this is a minus b, and I factor out, I want this to look like a minus b, what would I have to factor out? Well, I'd have to factor out a negative 1, because that'll give me negative b and positive a. Now, if I switch that around and just reverse the order of using the commutative property, that would be a minus b over negative 1 times a minus b. That makes the a minus b's identical, so we can cancel them. So this is going to be 1 over negative 1 is equal to negative 1. So basically what this says is, if you have these two factors, they're just the same numbers reversed when you're subtracting. When you divide them, it will always equal negative 1. And that is very, very important when you do that. All right, so which of the following is equivalent to 2x minus 10 over 25 minus x squared? Factor and cancel. 2x minus 10 is 2 times x minus 5. And then the denominator, 5 minus x squared. Notice the order on here. The 25 is positive, the x squared is negative. So actually, the plus and minus here, the x's have to go on this end because that gives you negative x squared. The 25 would go here and here. Okay, now, do you have any factors that are exactly the same? No. But notice this factor and this factor right here. They are exactly the same except for the sign. It's like x minus y, y minus x. So they will cancel each other but not equal 1. They will actually equal negative 1. So when these cancel out, this is actually going to equal negative 1. So 2 times negative 1 is negative 2, and then 5 plus x in the denominator. So this 5 plus x and x plus 5 are the same thing because the commutative property is same for addition. So that's actually going to be number 1. So if you have identical factors except for the order with the minus, then it will equal negative 1. And the Regents loves this question. All right, so let's save exercise 7 for class before we do the homework.